Good morning, sir. Archer unknown.
Hey, good morning, guys.
Morning, sir.
Good morning, sir.
Hello, sir.
Good morning, sir.
Good morning, sir.
Yeah, let's start today's class. Okay, so let's see views, system tables, and then db2 admin tools. So we have seen almost all the varieties of the select statement, and we have seen most of the scalar functions. Did I miss any scalar function?
Yes, sir.
What are those?
Replace round and length. Replace and round.
Replace, right?
Yeah.
Replace, right?
And you forget that any and any clause.
Any clause is not working actually there.
Yeah, that's
We'll see that little later. Maybe once I start the classroom trainings, I may explain it. Okay.
okay,
Not so
sir.
important. Not so important. Okay. Any, all, some, or all. We mean all.
Sir, your screen is not visible.
Yeah, I'll show it now. A replace is like this. For example, select by number. For example, there is an email ID. Assume like there is an email ID. Okay. If there is a hash in the place of at the rate, if there is a hash at the rate of at the place of at the rate, for example, Madhu hash gmail.com, which is not correct. So I want to change that to at the rate. In that case, so we use a replace email ID, comma, okay, hash, comma, like this we give it. So check this email ID, replace this character by this character from table name. I hope you understand.
Yes, sir.
So give the column name here. Check this column. If we have a hash stored in that column in any row, that should be replaced by @. Important note, we are using a select statement. It's not going to be replaced in the table. While showing it it will show you @ in the place of hash. But it's not going to be replaced in the uh, table. If you want to replace it, okay, you have to use a update statement like this. Update emp set set email id equal to replace email id comma hash comma @. Like this we give it. So this email id is so first of all, it's update query. Now the table will be updated. Wherever the email id is having a hash, that's going to be replaced with a @. So do you understand this?
Yes, sir.
Okay. So that's called replace. And in case if any missing commands are there, we'll see that little later. Let's move on to views. Right. So view is nothing but a subset, a select statement on a query, select statement on a table. For example, select star from emp. We got a 42 rows and 14 columns. Okay. Now, I don't want to give a permission for some users on a salary, bonus, commission, okay, on those columns, because those are sensitive columns. I don't want to give a permission to them. Even phone number, I don't want to give a permission to some users. So in that case, I can create a view on this table. See here. Let me create a view. It's a create query. Create view name emp underscore b10 underscore v1. A view name like this. Yes, do you understand? Create a view name as select employee number, first NME, last name, comma, work department, sex, okay, hire date, some columns like this from here. So my table contains all
What
the
is V1?
sorry.
V1.
Mm-hmm.
What
What is
is
it?
why? What?
No, I'm just giving a name. I can give any name here, but for better representation, I can give EMP1. Okay, I'm just giving just a name, any name. Your batch is batch 10, and this is a view 1. That's what I'm using some naming convention. EMP underscore B10 underscore V1.
Okay, sir.
Yeah, there's no much meaning here. Okay, so create a view name as select whatever the columns you want from the table name. Okay, from the table name. So now I'm creating a view. Now I'm creating a view. See here. It is created. It is created. Now you can execute queries on a view now. But view doesn't contain all the columns. View is not having all the columns. Sorry for that. View is not having all the columns here. View is not having some salary columns, bonus columns, commission columns, some phone number. I didn't select those columns into the view. So now, if you use a select star from view name here, columns are selected from the view. Only these columns are selected. So view is nothing but a select statement on a single table or multiple tables. Any select statement, you can create a view. You can create a view. So now I give permissions for some users on an entire table, and I give permissions on this view for some other users. So are we hiding the data or not?
Yes, sir.
So we are hiding some sensitive data. That's the biggest advantage of the view. But there is a disadvantage, I'll tell you, where work department equal to where work department equal to D11. See here, I have a view. My view is created on this select statement, and I'm writing a query on the view. So now if I execute this query, it is going to be executed twice. First, the view definition is executed. In fact, view doesn't store any data inside it. Table is going to store the data, but the view doesn't have any data inside it. But whenever I execute a query on the view definition executes. What is the view definition? Is a select statement. View definition itself is a select statement. Yes or no?
Yes, sir.
And I'm writing a query select statement on the view again. View itself is a select statement. I'm writing a select statement on the view again. Instead of using a table name, I'm using a view name here. That means if I execute a query on the view, it is going to be executed twice. First, view definition, and then executes a query on the selected data from the view, like this. So it is going to be executed twice. That's why performance wise, views are very, very poor.
Sir, if I created a view,
Mhm.
then I will update the main table like
Mhm.
IMP.
It
Then
will
auto.
reflect in the view. It will reflect in the view because view doesn't have any data inside it. Whenever you execute a query on the view, see here, I'm executing a query on the view. It will execute this select statement, the view definition, on the latest data of the table.
Okay, sir. Means doesn't have any store the data in
No,
view.
view, the object view does not have any data inside it. It will temporary, it is going to create a data temporarily when you're executing a query on the view. If you execute this second query, for example, assume this is the second query and this is the first query. This is the first query and this is the second query. If you execute this second query, it will execute the first query first. Then it's going to execute the second query. That means it is going to take the latest data of the table. Yes or no?
Yes, sir.
If any updates or inserts are done on the base table, this is the base table, this is the base table, and this is a view. I'm writing a query on the view. So now first the query is executed. The select statement given in the view definition is executed and it creates a resultant. From there, the select statement is executed.
Okay, sir.
Here, The advantage is we are hiding some information and we are giving permissions to certain group of the users on this view, not on the base table. They cannot see the salary information at all. They cannot see the phone number at all. They can see only the selected columns. Only these columns they can see. Of course, they want to see only employee number, first name, and they can use those columns here. So they can select only the columns available here, and they can select only the rows available here, not entire table. Guys, do you understand?
Yes, sir. Sir, if I change the name, like you written here, EMP B10 V1, and I changed like whatever the name was
You can.
previous.
You can.
So it will show this view or normal table, normal select query.
One was first we need to create a view. Okay. You can create with any name. You can put your name there. What's your name?
So there,
Let me create a table, a view with your name. Okay. I'm also giving where only female or male employees I'm taking here. I'm also using a where condition here. So I'm creating a view. It's created. Now, if I execute a query, something like this. Now, if I execute a query on the view name, first view definition, this is a view definition. It will be executed and it gives a result. On the result, this query is executed. What is your doubt here?
uh, sir, my question is that if you created the view, okay,
Mhm.
and you commented the create view,
That's already
and
executed. That's already
yeah,
executed.
yeah,
The definition is
that's it.
already executed. The object is
Yeah,
already
yeah,
created.
okay.
Don't
And
need to
we
execute
have,
the create query again and again. It's only one time. Create is one time. But you can execute a select statement on the view n number of times.
but I want to show the sensitive data also.
Then
So
you
I have to write,
go to base table. Then go to the base table.
yeah, means I have to write the EMP instead of Sudhir.
Yes.
Yeah,
Yes, of
okay.
course.
That was my question.
Yeah, I understand.
Okay, thank you.
So if you want to see the entire data, go to the base table. Or else you create another view with all the data. Select star from EMP. Create a view on that. What is the use of that? If you create all the columns and all the rows in the view also, what is the difference between a view and a table? No difference, right?
This,
Okay. Now I'll show you another best example. So I'm creating a, see here, select star from EMP, one thing, and select star from DEP. Yeah. So this is the EMP data, and this is the DEP data. This is the EMP data, this is the DEP data. See, there are some managers, right? Here you can see manager. Manager number is also employee number. Yes or no?
yes, sir.
So now I write a view with employee number, employee name, department number, department name, manager number, and manager name. Guys, do you understand?
Yes, sir.
So first of all, let me write a select statement. Select a dot employee number, a dot first enemy, comma, a dot, last name. Just first name is enough. No need to go for last name. A dot first enemy, name, a dot work department, b dot department name. I'm going to use a table B as a department table, and b dot manager number, and c dot, there is not fit, c dot first enemy as manager name from emp a db b, okay, and again emp c, where I'm using a join on 3 tables, where a dot work department equal to b dot department number, and b dot manager number equal to c dot. Okay, leave it. It's a little complex query. Okay, I want employee number, name, work department, department name, manager number, manager name. So to get the department name, I need to join a employee table and department table. To get the manager name, so manager number is available in the B table, correct? Department table. Manager number is available in the department table. Yes or no?
Yes, sir.
And I want a manager name. Is a manager name available in the department table? No. It's available again in the employee table. That's why I created I used another table, the same table, EMP table once again as a C. So A dot work department equal to B dot work department number, and B dot manager number equal to C dot employee number. So I'm joining this because employee table is a child table to the department table. Employee table is a child table for the department table. Correct? On a work department. And similarly, assume this is a manager table. Assume the employee table here is a manager table. On a manager number is a foreign key in the department table, and employee number is a primary key on the employee table. So now department table is a child table for the employee table on a manager number. At the same time, employee table is a child table for the department table on a work department. Do you understand? Okay, leave it. I'm not going depth into this. I'm not interested to tell about the joins here. My intention is to explain about a view. You'll see the advantage of the view here. Here, I got employee number, first name of the employee, work department, department name, manager number, and a manager name. Can you see that manager name here?
Yes, sir.
So now what I do is okay, and the 2 employees are not having a department. That's why we got only 40 rows. Now, if I create a view on this, create view emp underscore v10 underscore v2 as, this is my view. I'm creating this as a view. I'm creating this select statement as a view, so that if someone doesn't know how to join all these tables, I ask them to use this view so that they can access a manager number, employee number, department name, manager name, without knowing about how to join it. I just give this view to them, and I say this view is having employee number, employee name, department number, department name, manager number, manager name. I just tell them this view is having all these columns. You can use this view. So no need to understand how the join is created. Guys, try to understand. Yes, do you understand?
Yes, sir.
There is a complex join available here, and I'm creating that as a view, and I'm telling this view is having employee number, employee name, work department, department name, manager number, manager name. Without knowing about how these are joined, how many tables are used here, you can straight away use the view. Yes or no? Let me execute it. Yes, this view is created. This view is created. Now, I want a, okay. So I write a query, select star from the view name. I don't know how the view is created, but I know what are the columns available in the view. So here it's like this. For example, I want only this employee. Okay, I can write a query here. So select star from EMP, star from the view where employee number equal to, I want a, okay, employee number, employee name, manager number. For example, employee number, first name, and then manager name. There is a column called manager name. Yes or no? We have used a manager name. Can you see that? So I want a employee number, first name, and manager name. You understand this query?
So you wrote double quotation on the employee number.
No, single quotation. Here is single quotation only. So
So we
select
can
employee
provide.
number.
So we can provide on numbers also.
It's a character field, man.
Okay, 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 sir. Okay.
It's a character field. It's not a number field. Based on the field, the column, data type, we need to give a value. This is a character type. This is not a number type. Okay.
Okay, sir. Okay.
Though it's a number, but if you are using a condition on a character type,
Character
you
type.
have to
Okay.
put that value in the quotes. So select employee number, first name, manager name from the view where the condition. See here, I got it. Really, 1 second. I'll take another one. 050. Yes. Oh, these are all managers actually. They're all managers. It look like. Oh, what's happening? Something wrong with my query. Okay, let me execute it. Let me execute the query. Yeah. Take another number. So whomever I executed, all are managers actually. You can see. Here. So I want to know the manager of this employee. Manager name of the employee. So if you don't have this view, you have to join all these tables. Yes or no?
Yes, sir.
But if I have a view like this, if you have a view like this, which is already defined, I have employee number, employee name, department number, department name, number, manager name. All these columns are available in the view. I can write straight a query on that view instead of writing a query on the base tables. See here. So employee number is this one, employee name is this one, and manager name is this one. So what do you understand from here? We can hide the sensitive data. Do you accept it?
Yes,
If we
sir.
give permission to a view, if you give permission to the view, whatever the column selected in the view, only those columns can be viewed by the end users, accessed by the end users. So that's the reason we can hide the sensitive data. Number one. Number two, we can hide the complexity of the query. Yes or no? End user need not know about how this query is built, but end user knows about what columns are available in this view. Without knowing about this complex joins or a complexity in the query, they can straight away execute a query on the view. You don't know how to join it, for example. But I'm saying this view is having a employee number, name of the employee, work department of the employee, department name of the employee, manager number of the employee, and manager name of the employee. Okay. Now we can use that view. Can we hide this complexity of the query? Not hiding. Can we can write views on some complex queries so that end user need not worry about that complexity. They can directly use the view. Do you understand?
Yes, sir.
Yes, sir.
So these are advantages of the view. These are advantages of the view. We can use a view with a select statement, any select statement. That may be unions, that may be joins, that may be correlated subqueries, that's normal subqueries, whatever it is. The view definition, the select statement used in the view definition may contain any select statement, maybe aggregate functions, scalar functions, anything. Okay. And this view, okay, let me show you. Here I have created a view. Select employee number, first name, last name, work department, sex, height. Can I update this view? Can I write an update query on the view? Do you understand the question? Can I update data in the view?
Yes,
Can I
sir.
update queries on the view? Update queries on the view. Yes. For example, I want to change the hire date of a given employee to some other date. I want to change the work department of a given employee. I can change it. Okay. So if you don't have a aggregate functions, for example, there is a count star. There is a count star. Department wise employee count is there. We cannot update that count. We cannot update the department. So if you don't have aggregate functions on a given column, so if you don't have aggregate functions, if you don't have some arithmetic operations, for example, there is a salary plus bonus plus commission as a total salary, but we cannot update a salary through the view. I have selected total salary in the view, salary plus bonus plus commission. Guys, do you understand?
Yes.
So I have selected salary plus bonus plus commission as a total salary selected in the view, but I cannot update only salary part there because this is a combination of all the three columns. So when I use arithmetic operations, those columns cannot be updated. Okay, and if I use a group by clause, I cannot update that rows in the view from the view, rows from the view. An important note: if you update this values in the, for example, I want to change the department name number of a given employee. So employee number is there, work department is there. I want to change the work department for a given employee. So I can write a query on this view. So update the view name, set work department equal to some C01, where employee number equal to so and so. So we have the columns and we have all the columns available here. Whatever the columns I'm updating, whatever the columns I'm applying conditions are available here. Yes or no? I'm updating a work department and I'm applying a condition on an employee number. So both are available in the same select statement of the view. Yes or no?
Yes, sir.
So in that case, we can update it. But if it is having a group by clauses, okay, we cannot update it. If a column is derived with a arithmetic expression, that we cannot update it. Okay. So now the question is, can we insert a record? Okay, very important thing. Very important thing. If you update a row from the view, it is not updated in the view. It is updated in the base table only. Because view is not having any data inside it. View is going to show you the data from the base table. That means if you update anything in the view, it is updated back in the base table only. Do you understand?
Yes, sir.
So here few points are there. Updatable views and read-only views. That means if you want to update a record from the view into the base table, okay, that select statement of the view definition should not have a group by classes, should not have a joins, should not have some arithmetic expressions. If there are some plain columns selected, then that plain column can be updated. Are you clear with this?
So if you want to update or insert, then we have to write the base table name or view.
View. You can update through the view. For example, I'll change it here. Let me change it here. I'll change the work department of one of the employee or last name of the one of the employee. Let me show you. Let's see what is the values available. Yeah, here I'm selecting. Select star from EP, right? Okay. For example, here is a Haas. I want to make that as a 1 second. I think it's not possible. Last name, right? Yeah, I want to change it as a Suhas. Suhas instead of no, not that. Okay, yeah, Suhas. Okay. Now I'm writing update query. Before that, I select star from the view name. See here, I'm writing a view. Select star from the view name. This is my first query, and I'm updating here. Update the view name. Set last name equal to Suhas. Okay, where employee number equal to 00010. And again, I'm selecting it. So I want to show you what is the value before update, what is the value after update, and or else I'll show it here. Employee table, not the view. I'll select data from the employee table. Yeah, do you understand? Selecting
Yes.
data from employee table. Again, selecting data from employee table, but in between I am updating it. You understand? And also I am using a commit. There's one more statement, commit, so that the changes will be committed. It will make that as a permanent changes. So selecting the data before we update the view, selecting the data after updating the view. Do you understand?
Yes, sir.
So I'm updating the view only, data in the view, but it will be updated in the base table. That's what I wanted to show you. If I update the data in the view, it's not updated in the view, it's updated in the base table only, because view doesn't have any data inside it. Okay, see here.
Okay, sir.
So what is the name here before update?
Ash.
Pass for the 0010. Let's come down. Yeah, my update query is successfully executed and it's committed. And what is the name appearing here in the base table?
Yes, sir. Done, sir.
Suhas. Guys, do you understand this concept?
Yes, sir.
That means can you update the data in the view? Yes, we can update. It will be updated in the base table. Can you insert a record through the view into the base table? Yes. If all the columns are selected, at least all not null columns are selected in the view definition. No aggregate functions, no scalar functions, no arithmetic operations, no joins. The view is selected with all the not null columns. In that case, maybe you may have where conditions, no problem, but it should have all the columns, not null columns, selected in the view. In that case, you can insert a record through the view into the base table. Are you clear?
Yes, sir.
But in this through this view, I cannot insert a record because there are some not null columns which are not selected here. If I try to insert it from the view, it will fail because some not null columns are there in the base table other than this, which are expecting some values. Yes or no?
Yes, sir.
If my view is having all the columns, not null columns of the table, and no joins, and no arithmetic expressions, and no some constants. For example, sometimes we use also constants or string manipulations. If you don't have any of these, if plain columns are selected, you may have where condition. But all not null columns are selected from a single table without a group by, without a aggregate functions, without a scalar functions, okay, without arithmetic expressions, then we can insert a record from the view into the base table. Are you clear?
Yes, sir.
Yes, all of you.
Yes, sir.
Yes,
Sir,
sir.
sir, I have a question.
Go ahead, please.
Sir, I have created on EMP table view, but I want to remove.
You want to drop the table view?
No. I want to just remove only view, not a table.
You can drop that view. You can drop the view. Let me show you that. So I'll drop the view which is created on the Sudhir, right? So here I write a query like this: drop view, the view name. Do you understand? Drop view name. It is dropped. That's right. Here. It is dropped. The statement execution was successful. SQL code is 0. Are you clear?
Yes, sir.
Okay, that's all about the view. And we use views extensively in the real applications, and you may get some questions on these views. So what is a view? View is nothing but a select statement. Maybe in a single table or multiple tables with the joins. or maybe subqueries, maybe anything, any select statement, maybe unions. You may have unions in the view. Any select statement can be created as a view. Okay. So performance wise, views are very poor because it is executed twice. Yes or no?
Yes, sir.
First view definition, and then on the resultant of the view definition, it will execute one more query on the view. But it has some advantages. We can hide sensitive data. We can hide some complexity of the queries. Okay. Okay. And there are two types of views, like read-only views, updatable views. Okay. So read-only means you cannot update it, you cannot insert it, you cannot delete it. We cannot delete records from the view. We cannot we cannot insert records. We cannot update records. Yes or no?
Yes, sir.
Yes, sir.
So if you want to insert a record, you must create a view on a single table without a joins. And it should have all the not null columns. Then only you can insert record through the view. Then only it will be inserted in the base table from the view into the base table. Ultimately, the record is inserted in the base table only. Okay. So if you want to update it, if there is a plain column selected in the view, we can update it. But if there's arithmetic expression, if it is created on a joins, no, we cannot. If there is joins, we cannot insert or we cannot update, we cannot delete it. If it's on single table, if all the plain columns are selected without a arithmetic expression, without a scalar functions, without aggregate functions, we can update it. If all the plain columns are selected, all the not null columns are selected from the single table, we can insert it. Okay. Delete is simple, almost like update. Delete is almost like an update. Okay. So we can delete records from the table if it's from a single table without a aggregate functions, without a arithmetic expressions. We can delete it.
Sir, what is your first view?
What is that?
First view.
First view created here.
No, not a first. Force. FORCE. Force.
Force. Did I give it here? You're talking about this?
Yes, sir.
No, I don't. I didn't say about this. There is no concept of force here. Okay. If you understand, I'll go to the next topic.
Yes, sir.
Okay. Thank you. See, db2 is very, very interesting, man. A lot of logical thinking is there. Okay. Comparatively, other subjects, SQL is very, very interesting. Those who buy hard things, this is not the right place, because we need to apply some logical thinking here for a db2 to pull the data, to insert the data, to update the data, especially selecting the data. Okay, and many people they are failed in answering the interview questions on SQL queries because it needs a lot of practice. It needs a lot of practice. Very important thing. You should not see a single question as a strange question in the interview. If you get any question as a strange question which is not heard about it before you attend the interview, so you need to spend time to think about it and to bring into the solution. That's why, because we don't have much time in the interview, right? We'll have hardly few seconds of time to think about it and then to write a query. That means every scenario you should go through that before you attend the interview. That means you should have a lot of practice. If they ask you, get me the highest salaried employee details, can someone tell me what is the query for that? Highest salaried employee details, max salaried employee details.
Sir, we use max function, aggregate
Right.
function.
Tell me the query. Select max.
Select max salary from the EMP table.
But this is not the question I asked you. Max salaried employee details. Are you giving any other details other than the maximum salary? I asked you, get me the max salaried employee details.
Sir,
You are
Fetch
giving
one, fetch first row only.
That's good. That is one answer. And we can also give another answer. Yeah, what you said is right. Select star. Girls, please go to mute. Guys, please go to mute. Select star from EMP. Okay.
Where salary equals to select max salary from employee.
Sorry.
Next step is where salary equals to select max salary from employee.
Exactly. So we need to write a subquery, or else we need to write a fetch first one row. So you need to come to this much faster. You need to come to the conclusion much faster. So that means if you already gone through that, then only you can bring that answer, right? If you know this question, if you already exercised on that, then only you can bring into the result. You can bring into the answer. Otherwise, it's very difficult. That's why a lot of practice is required for the SQL queries. Okay. Fine. There are two ways to get the max salaried employee details. Number one, using a subquery. In the subquery, we select the maximum salary. In the outer query, we select the all details of the employee, where salary equal to the return maximum salary returning from subquery. So this is how we do it. Second answer is select star from EMP. Order by salary descending. Fetch first one row. Okay. Let me move on to the next topic. Okay. Now I'll show you some db2 admin tool. So before that, we should know some system catalog tables. System catalog tables. For example, if I create a table or a view or alias or synonym, whatever it is going to create an entry in sysibm dot systables. Sysibm dot systables. Sysibm dot syscolumns. Sysibm dot sysindexes. Sysibm dot sysrelations. Like this, a lot of system tables are there. So what is the information stored here? If I create a table, for example, If I create a table, create table, okay, table 1 with some columns. Column 1, okay, definition. Column 2, definition, and then column 3, definition. If I create it like this, okay, then it is going to write one record. That's not a data of the table. It's going to write one record in this sys tables. So saying that, what is the table name? Who created it? When is that created? How many columns are there? Okay, when was that altered last time? In which database that is created? What table space that is created? It will give a lot of information. Guys, do you understand?
Yes, sir.
It gives you a lot of information about a table. Let me show you that. I'm writing a query here. Select star from sys IBM dot sys tables where, okay, name equal to a table name. The table name is A. Sorry. Yeah, comma is there. Error. Here, name of the table is employee table. Creator is a so and so. Type is a table. If it is a view, V. If it is alias A. If it's synonym S. Like this, it will have. What is it? In which database it is created? Which table space it is created? Okay, not all the columns. And how many columns are there? 14 columns are there. And how many pages of data is there? 2 pages of data is there. And how many parent tables are there for this table? How many children tables are there? Child tables are there? How many columns are there? Key columns, primary key columns are there? What is the record length of this table? That means I have 14 columns. What is the total length of all the 14 columns? So like this, we get a lot of information here. Do you understand?
Yes, sir.
Right? So it gives you created timestamp, altered timestamp. When was this created? When was this altered? Okay, like this, lot of information we can get it from the table. Not the data of the table. Information of the table, not the data of the table. If you want to get the data of the table, you need to write a select statement on the table. Are you clear?
Yes, sir.
Okay. Similarly, if I want to get all the column level definitions of this table, so TB name here, not a name. So I'll tell you here. We have only one record for this table in the sys tables. But how many columns are there in the table? We have 14 columns. So there are 14 rows available in the sys columns. Each row tells about each column information, not data. Not data. What is the column name? What is the data type? What is the length? Is it a null or a not null? When was this created? When was this altered? Okay. So like this, we get some information. Do you understand?
Yes, sir.
Show you that. So employee number, first name, middle initial, and then last name, work department, phone number, like this. These are the column names. And what is the table name of all these columns? Same table, EMP table. That's I have given a query on this table name only, where table name is EMP. Who is the creator of these columns? And what is the column number in the table? Is the first column, second column, third column? And what is the column type? What is the length? If it is a decimal, then scale. If it's a decimal, then it's a scale. So decimal 9, 2. Do you understand? Does it allow nulls? No, it doesn't allow nulls. For these columns, it doesn't allow nulls, but for these columns, it allows nulls. Guys, do you understand?
Yes, sir.
Can we update the data on the column? Yes, we can update the data on the column. Some columns may be non-updatable columns. Okay. So what is the key? What is the primary key of this column? This is the primary key. Can you see that key sequence? If it is greater than 1, then it is a primary key. So like this, we can get a lot of information from columns. So where is that stored? sysibm dot sys columns. And these sysibm dot sys tables, sys columns, this type of tables are called system cataloged tables. Cataloged tables. It doesn't store the data, but it stores the information of the tables and columns. Are you clear?
Yes, sir.
You know very high level information of this system tables. So now I want to know how many indexes are created on this table. Let's start from sysibm dot sys indexes where db name equal to emp. Only for the sys tables only it's name. In all other tables it's a tb name. Table name. Okay, is a emp. Let's see how many indexes are created on the table. I told you the mandatory indexes are required on a primary key and unique key. Yes or no? Mandatory indexes must be created on a primary key and a unique key. Otherwise, you get minus 540 as SQL code. Did I say it or not?
Yes, sir.
While creating a table, while creating index, I've shown this.
Yes, sir.
So now, how many indexes are there on this table? Let's see that. There are two indexes, xemp1, xemp2 are the index names. Okay, like this, we can find a lot of information from the system catalog tables. I want to know what is the parent table. What are the parent tables for the employee table? So select star from sysm.sys relations. See here, sysm.sys relations where db name equal to emp. How many parent tables I said? Only one parent table. Let's see what is a parent table. This is a table name. Referential table name is nothing but a parent table. So this is a parent table. Guys, do you understand?
Yes, sir.
So how many parent tables are there for the employee table? Only one table. That's a department table. I want to know what are the child tables of the employee table that is available. Okay. Now, if I write a query, so I'll take a continuous class up to 10:45. Then I'll wind up it. And please plan yourself to come to a classroom. I don't like this online training at all. So classroom training will be far better than this for sure. I promise you. Okay. So select star from sysm.sys relations where referential table name equal to emp. If I give a referential table name, that means it's a parent table. I want all the child tables of the parent table. Parent table is my employee table. So let's see. I've got 3 tables here. Okay, it's a creator actually. Let's go to the right side. And department table is a child. Project table is a child. Employee project is also a child. Sorry. Yeah, it's all. These are all child tables. These are all child tables. All the 3 tables are child tables for the EMP tables. EMP table. Guys, do you understand What type of
Yes, sir.
information is stored in our system catalog tables?
Yes, sir.
It's not a data. It's not a data, table data. It's not a table data. It's not a column data. It's the information of the table, the information about the column, the information about the indexes, the information about authorizations. Are you authorized to execute a query on this table? That also we can find it from the sys authorizations. So instead of going and executing a queries on this table, on the system tables, we can use a tool called db2 admin tool, db2 ADM tool, db2 administration. Can you see that? db2 administration. Okay, in that one system catalog. And here I'm giving EMP table and I'm selecting T. And all the table names that starts with EMP is shown here, are showing here. Okay, no worries. Now, hold a second. Guys, I'm sorry. So let's come back here. Now, if you want to find out the parent tables for this EMP table, so PA is a command PA. Did you get it? No need to write a query. We can directly use a command. If you have an admin tool, for that such information, we can write a command. PA is for a parent table. CH is for a child table. See here. What is the primary key? PK. What is the primary key of the table? PK. This is the primary key. And what is the foreign key of this table? FK. We can simply get it. What are the indexes available on this table? X. How do you know all these commands? Simple. Give a question mark. Not all the commands are important. Okay. Some of the columns. So for example, I want to see the columns of this table. I give a C. I want to browse the table without writing a query. BR. Okay. I want to see the what database and what table space this table is created. This is my database name. This is my table space name. Who is the owner of the table? How many columns are there? How many rows are there? How many check constraints are there? So we can see get such a lot of information from the db2 admin tool. Guys, do you understand the advantage of the admin tool?
Yes, sir.
Instead of writing a queries on a system catalog tables, what information is stored in each of these tables? We can straight away go to the db2 admin tool and we can use some line commands. If you don't know the line commands, give a question mark. The line command, its meaning is given in the right side. So line command and a description. For example, I want to see the columns, show columns. I want to browse the table, BR. Let's see here, BR. See here, BR. So do you understand? And let's see some of the important line commands available here. I'll list out all those. Line commands. Description. Not all. So BR is for what?
Browse.
Browse the table. Nothing but a select star. We can't use conditions here. Nothing but a select star from the table name. Instead of using a select star from the table name in the spoofy, we can go to the admin tool and we can use the BR command. Are you clear?
Copy.
One second.
Column name.
One second. So show the columns of the text. Yeah, this is not required. Column distribution and all, it's not our duty. Tail table, CH, right? Show tail
Child
tables.
table.
CHK, check constraints. Let's see. CHK, check constraints. We have 4 constraints available. What are those?
Primary, unique, foreign key, and check constant.
Right. So here, if I use a CH, if you use a CHK, then check constraints. It will show you check constraints. Okay. Check constraints. Let's see. You have to give a yes here. Yes. If you are outside this, you can give a CHK. Or else if you are inside it with a question mark, and you have to give a, okay, see here, yes, execute the line command. Yes. So how many check constraints are there? If it is a sex, okay, it must be either a male or a female. If it's a phone number, think about 1970s. The phone number was only 4-digit number. 1970s, I'm talking about 1970s. It was only 4-digit number. Okay, it should, the allowed value is a 0 to all 9s. Yeah, simple constraint. Don't compare it with the current numbers. But do you understand how to check the constraints? Check constraints.
Yes, sir.
In case if you get a, I'll tell you, in case if you get a minus 545, what is the meaning of that?
Check constraint error.
Check constant
Right.
violation.
I'm trying to insert or update a record in a table and the check condition is violated. If you get the check condition violation, then come and check the check condition here. Why it is violated? What is the value you are supplying and what is the value it is accepting? Then you can correct your coding. Do you understand?
Yes, sir.
Right. So give a question mark here. Let's go. Yeah, child relations. Okay. So on what? Yeah, just child table names are child relations. Both are same. CH and CHK, CH and CHR, both are same. I think some count star is there. Count star, where is that? Show constraints, all the constraints. I'll show you here. CON, all the constraints. Here, primary key. Sorry for that. It has a, this table is having a 4 constraints. 1 primary key constraint, 1 foreign key constraint, 2 check constraints. There is no unique constraint here. If you have unique constraint, it will be U. Okay. If you want to see columns in the constraint, see here. From here, I can use a CC. What is a column? Okay. Or else, see here, CC. So, work department and then department number. So, this is a child table column and this is a parent table, primary key of the parent table. So, I hope you understand. If you want to see all the constraints, use a CON. Okay. image any command. brc, important, brc chk con. Show,
Show all constant.
right. Then count. It gives you number of records. Okay. In the table. So instead of writing a count star, it is a count. See here, I want a count. How many rows?
42.
Right. You can get such information from this, line commands. Make this count. We will not have access to this create a similar object. Okay, we will not have access for this because we are not authorized to create the tables, alter the tables. Okay, so all these are executed by DBS, not we. So show database, in fact, database show table space is not required because in the main panel itself, you can see the database name, see that, and table space name. You can see here. Do I need to write again a D here?
No, sir.
This is available in the same panel. So number of records are also available here. No need to use a count. How many rows are there in the table? We got it here. Okay. Fine. Give a question mark. Right. Next one. Actually, DDL is very, very important. Unfortunately, it's not working in my system. That means it shows you create a table query. Create table query. If you have a create, so for example, the create table was created long back. Table was created by long back, and it is altered n number of times after that. If you want to see the latest create table query for that, you can get a lot of information, right? What are the columns? What are the data types? What are the lengths? And what is the column option? Is it a null or a not null? Okay. And what is the constraint? Can't you see all this? What are the parent tables of this table? Because we can see foreign key definitions. In which database is created? In which table space it is created? If you know the create table query of a given table, it gives you a lot of information. Yes or no?
Yes, sir.
That table was created long back, but still we can see the DDL. So if you use a DDL, it will give you all the information of the table. Information of the table, not the data of the table. Okay? So, but it's not working. So DDL gives you create query. Which is very, very important. Mostly we use this one. And delete a row, we don't delete from here. We write a delete query in the spoofy. It's a data manipulation, right? DML, right? Is it an object level information or a DML operation? Deleting a row from a table. It's not object level information.
DML.
DML.
We can do it in a spoofy. No need to come here for the delete a row. Drop the table. We don't have access. Who is going to do that? DBA. Okay. I don't know this one. Yeah. Database structure. This is the database. This is the table space. This is the table. Okay. And these are child relations. This is the parent. And then this is a primary key. These are check constraints. These are indexes. Can you see that? And these are all views created on the table. This is also very important. Okay. So what is this command? This command. DS. Very important. Okay. Hope you understand. DS. Once again, we'll see that. Hierarchy. See here. This is a database. And this is a table space. And this is a table.
Name.
And Y is like a synonym. I think Y is a synonym. 1 second. These are all the child relations and parent and primary key, and then check constraints, indexes created on the table, views created on the table. So we can see all these information about the given table. So database structure. What are all showing? Database, table space. Okay. Constraints.
Constraints.
Okay. Views. If you have triggers,
Indexes.
So it gives you complete information on what are all the objects created on this, right? On top of that and under that, on top of it and under that, and bottom of that. Okay, it will show you the entire database structure of a given table, which is useful. Next. Yeah, this is also useful. We'll see that more into application programs like that. It will show you what are all the programs used on the table, what are all the, yeah, it will show you here. It's running. See here, X system means it's running. That means that this query takes more time. It has to check all the packages and plans. So these are all plans. We'll see that later. These are all the packages. How many programs are using this table? How many programs are using this table? This is very, very useful in a impact analysis. Okay. So we'll see that again in the database structure along with the packages and plans. We'll see this later in the application programs. So how many programs are using this table? Is it useful or not? Definitely useful information. FK, what is that? Foreign key
Foreign
definition.
key.
Okay. Not required. We don't use it. Grant privilegization, generate SQL, grant privilegization. Details on a table or view. Yeah. Same. Like sysIBM.systable information is shown here in a single panel. sysIBM.systables. sysIBM.systables. One row is selected from sysIBM.systables. If you want, I can show it here. Same information what is stored in a system.sys tables is available there. So see here, name of the table, okay, and then table owner. Let me show you. Creator, okay, and then type of the object is a table. 1 second. That information is database name, table space name, database name, right? Maximum row length. We have seen somewhere. Yeah, record length, correct? Status of the table. Here, X. That means it is showing a record from the system.sys tables. Instead of writing a query on the system.sys tables, we can use this information. Do you understand?
Yes, sir.
What's that command? From sys IBM dot sys tables. Next one. Yeah, if you have a triggers, I'll show you. I'll tell you later. Okay. Triggers. We'll see that later. You can create triggers on a table. For example, there is a trigger created on the employee table. So employee salary cannot be given, cannot be updated more than 100%. Assume there is a trigger. Employee salary cannot go more than 100%. If you are giving a hike, if you are updating the salary, you cannot update more than 100%. Do you understand? We can write a trigger like this. We can create a trigger on the employee table. Or else, I have a stock in my store. If my stock is falling, for example, maximum stock is 100 numbers. Maximum stock for that item is 100 numbers. If the stock is falling less than 10%, then order has to be raised on that particular item. Do you understand?
Yes, sir.
So we can write some triggers like this, atomic actions. If this is happened here, another action is happened there. We can write that triggers on a table. Okay. So if you have such a triggers on a table, we can see those triggers from this db2 admin tool using a line command J. It shows you trigger. We'll see the triggers later. What are all the programs using this table? They're all the programs that are using this table. Okay. So, K, the packages. Package means program. Package name and program name is one and the same. That's why let's see package. Package on a given table. Let's see quickly. Okay. Yeah, it's almost like constraints. N is also same as a C. C by N. PA is for a parent tables. PA, parent table information. These for plans. We'll see that later. Package and plans, we'll see that later in the application program related things. These two are application program related things. So I cannot explain at this moment. We'll see that later. Guys, do you understand the advantage of the admin tool?
Yes, sir.
If you don't have this, we need to write some queries on hundreds of system catalog tables. I'll show you what are all the catalog tables available. here 184 system catalog tables are there. To get us some information, writing a queries on this system catalog tables is very difficult because I should know what are the columns available on each of these tables. So each table is having some 10, 7, 5, 16, 33. See that how many columns are there? This table is having 55 columns. So the tables information, columns information, constraints information, index information, okay, authorizations, views information, everything is stored in this system catalog tables. Database, table space, a lot of information is stored here. Not the data of the table, it's the information of the objects. Okay. Instead of writing a queries on this, okay, for example, system.sys triggers. If you want to know what are the triggers available, you need to go to the system.sys triggers. Okay. Trigger 8. Let me show you the trigger 8. So if you don't have this, okay, if you don't have this admin tool, we need to write queries on system catalog tables. I hope you understand.
Yes.
So some of yes, we get this access only for browsing the data but not updating the data. For example, I shown you some of the create table, alter table, a drop table. I showed you like there are some commands here. There are some commands. Did I show it or not? Some of the commands drop. For example, drop object. You may not get access for this. If you try to execute this one, it will say you're not authorized. Okay, grant. We cannot give a grant permissions. Granting permissions, taking the permissions back, revoke. You can see revoke RV somewhere. Revoke somewhere. Revoke permissions. Somewhere it should be somewhere. So G is a grant. Where? Grant permissions. Leave it. So here's a grant. There must be revoke. So we cannot grant permissions. We cannot grant permissions. Yeah. Grant table. C or grant privilegizations. C in the R. Remove actually. I don't know where it is available. Okay. Anyhow, not so important. Okay, shows views on the table. How many views are there on the table? These are all the views created. Okay, these are all the views created. So these are all the commands which are very, very useful. And permissions are given only for a select. For example, browse the table. Are we updating it? No, we're just browsing the data. It is allowed. Show the columns. Are we updating the columns? No, we are just seeing the columns. Show the child tables. Show the check constraints. Show all the constraints. Show the count. Show the DDL. Create table query of the table. Show the database structure. Show the database structure with the packages and plans. Show the foreign key. Show the information of the table. Show the triggers. Show the package. Show the plan. Show the parent tables. These are all, we are just selecting the data. Yes or no?
Okay.
We are not updating it. Create table, alter table, drop table. We may not have permissions for that. Grant privileges, revoke the privilegizations. We may not have permissions for that. But we will have permissions for these commands. Okay. Yeah, I'm running short of time. Thank you for your time.
Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.